time.
Stand there.
And, just tell me if you don't hear me. I think we are loud enough for this whole group of people. Sohail.
Yes, sir.
I've heard so many good things today about processes, about different ways of engineering plants and building my feed mill. But my experience shows me that we normally run into trouble when we have a flow sheet where everybody has put their theory into that flow sheet and says this is going to work. And then I get into a situation when I build that plant and suddenly find out that maybe the sizing of elevators are not correct, the processing doesn't work, and sizing of the equipment doesn't fit to what I'm really expecting. And I actually heard that you have come up with a solution, Sohail. And maybe you can tell me what I can do to make that life better.
Well, I'm very happy, Marco, you're bringing that up. The problem that you are suggesting and mentioning is not unique to the feed industry. Guess what? In building any plants anywhere in the world, when it comes to mining, pulp and paper, oil and gas, anywhere, metals, they all have the same problem. We're all engineers, we're all basically humans, we make mistakes. So the question was, when we are designing the PNID, in the detailed design, how can I validate it and make sure that the design, the process will work? How can I make sure when we start, after ramping up, after a year of operation, when we want to expand, actually the process works? And that's something that we've been doing in Andritz. Have you heard of Andritz?
I certainly have.
Okay,
that's why I
perfect.
came to you.
Yeah, well, I'm sure that you know that we are for 180 years we've been building machines and equipment for feed industry, but we actually have 2,200 automation and digitalization engineers around the world. We do have softwares to simulate and model the entire plant. And this is something that we are bringing now to the feed industry. A software and the technology for the last 20 years used in mining, in pulp and paper, and in the metals and hydro. Today, I want to bring it live for you, a feed plant that we have built a model for in the ideas model. So if you can see, this is a 20 ton per hour poultry feed plant. If we have the PFD or PNID, we are able to bring it live and run it for you. Are you interested in that, Marco?
I would certainly like to look at that one.
Okay, so let's look at that then. Let me just right now show you the world's first digital twin. I'm sure that you heard about digital twin everywhere.
I did so.
Perfect. But this one is actually something based on first principles, physics and chemistry, that we are able, that we build in the ideas software, which is Andritz software. And what we do is that we bring all the equipment data sheet, the PNID design, the flow diagram, the mass balance, as well as anything that is considered on the physicals, on the equipment, where the equipment is placed inside the plant. We build that inside our dynamic model in the objects, and then we can bring it live. Is that interesting, Marco?
It certainly is. Please continue.
So, Marco, are you interested to know how we actually can trace the particle size distribution in the entire plant, the energy consumption, the throughput, the quality, the actually amount of the moisture that is coming outside of the pallets? Everything can be modeled and is modeled inside our simulation and the model. Like, for example, let me dig in a little bit. This one is we modeled it from trucks coming in all the way to the trucks going out. But let me dig in a little bit here. Right now, this model is running in real time, 10 times faster actually. And let me come to the Optimal here. And what
with the Optimal, which is a grinding process. Correct.
There, exactly. And in this grinding process, I can actually see my power consumption in real time. As I said, we are running around, if I can show you as a faster than real time. I think 200 faster than real time we are running. So I can look at the power consumption, but let's look at the particle size distribution that is coming outside of my Optimal. And then we can have different scenarios and look at actually, is this particle size distribution is what we are looking for and we want, or is this something that we need to change? Would that solve your problem, Marco, on the design and when you run this plant and with your engineers and look at different scenarios and see if there is any mistakes made?
That's what I'm looking for. That is, if I define what I'm looking for through my processes, I want to be sure the way that I've designed it will actually in practice work the way I'm looking for it to work. And
perfect.
This would be perfect.
I am glad to hear that. I was not expecting anything other than that. But let's see what are other applications of this, because the story doesn't end here. Do you have problems on the commissioning time, Marco?
I thank you for bringing that up. I have two problems. I have one problem is if I build a plant, I normally have operators which I have to count on that run the plant afterwards when it started up. I have very big difficulties in getting those people trained, getting them trained on time, and then at the same time when I go into commissioning, startup, ramp up, I lose so much time because we are starting to fix problems which we didn't see before, and I just want the people to understand what they have to do when problems arise, and this training is something that I would like to do better than we have done until
Perfect. Now. We actually have that solution for you. And it happens that this problem, again, is not unique to the feed industry. In mining, in pulp and paper, anywhere in the world. And then you know what? Let's look at those industries and see how they solved it. I'm proud to say for the last 25 years, we've been using this technology to have virtual commissioning. So let me show you how it works. We actually are able to decrease all to decrease the problems that arise in the commissioning. So look, if I am able to build a fully dynamic model that represents the reality of our plant, and we check everything that the design is right and there will be no surprises on the estimation, on the basically design, then we are able to connect this to the control system that is actually built prior to the plant going for commissioning. We actually are able to connect the control system to the operator screens that allows same operator screens that the operators will see inside the plant. Now, 2 months or 3 months before the plant starts or going to commissioning, we sit down with you, your engineers, and start the plant virtually, live. And we are able to go to the hot commissioning and find any problems that we might face inside the actual plant, but before, and then solve them and make sure that all of them are addressed. Is that something interesting for you, Marco?
We waste a lot of time if we go to site and we have the problems in commissioning, so that would certainly be something I would like to see more in detail.
That is great. And then, sometimes what we have found is that we are able to find 82% of the problems before going to the commissioning. And these are the projects that we have done. So for more than I can tell you, hundreds of these projects. This is the consolidation of the numbers and the problems that we see to verify the logic of the control, make sure that everything is tuned before the startup of the plant. And the only thing that we cannot find is the field problems. And I'm sure that that's something that you might be asking, well, what about the field problems? Because at the virtual environment, we cannot find the field problems. And the answer is, majority of the problems that we face at the commissioning, the time that is wasted is to troubleshoot of where the source of the problem is in the process. And now if we have made sure that all those soft problems are taken care of, then we know where to look, and that is in the field. Does that make sense?
Absolutely.
Perfect. Now you told me something about the training of the operators. And that is, I want to introduce to you the operator training simulator. Similar as when the pilots get trained in the airlines, we have built the operator training simulator and the training courses to train the control room operators so that they can actually practice operating the plant, deal with the problems that arises. They practice the startup, they practice the shutdown multiple times so that they are ready when the day comes to start up the plant. We have a software called Instructor that throws the operators into many different scenarios that can happen. So for example, equipment shutdown, equipment failure, problems with the feed and the changes in the quality of the feed, changes in the temperature of the environment. And then the operators, without knowing, they have to deal with that. And our instructor allows them to allows them to actually, in the courses, show how much they have improved, and then give you as a manager, tell you the indication if they're ready to actually start operating the plant.
Wonderful.
Marco, do you want to know what is the end result of all this?
You will tell me, and I really look forward to seeing that.
So, can I ask you something? How long is the ramp up inside the feed industry? How long does it take to get to the nominal operation?
It varies very much what you're doing, what kind of people you have. But you surely, if you want to come to a level where you say this is 100%, we are surely talking about 2, 3, even 4 months before you even get to a level where you are satisfied.
Interesting. So 3 to 4 months, and then they have, what I'm understanding is that they have to learn to use and ramp up, get to the nominal operation on all the different recipes that they have.
And optimize.
And optimize.
Yes.
So what if I tell you that based on all our, based on the technology that we are bringing and our experience for the more than hundreds of applications that we had, we actually can decrease that ramp up time by 20%. And this is one of the examples. This is a real example of a project that that our customer, the blue line shows similar projects that they had before. The red line is what they were expecting in the ramp up time. And the green line is actually what they got, which is in this particular phase was 4 months faster in a 12 months ramp up time. Now, in the feed industry, if it's a 20% faster ramp up time, what does that mean for you?
I mean, the quicker I get my products out into the market, the quicker I start earning money. And every month I earn money earlier is money in my pocket. Much.
I would love to hear that. So let me conclude something. This is how the operational readiness that Andritz is bringing to the feed industry works. We will completely train the operators before the plant is built. We are avoiding any engineering surprises. And at the end of the day, 20% faster ramp-up time.
Absolutely. And I'm looking very forward, and you have convinced me, and we'll make this happen. Thank you very much.
Thank you very much, Marco.